Hello, everyone. We're on Unit 1, Section 2. That is page 5 in your book. If you don't understand what I'm saying, you can always scan that QR code and listen to the genius that made these worksheets. We're going to be doing some review information of what you've already learned. We're solving linear equations for Common Core Algebra 2. Linear, that means a line. It also means the highest exponent is going to be a 1. So solve each for the following linear equations for the value of x. Now it says a value. That means that we are probably going to be getting a number for each one of these. I like drawing the big line through the equal sign. And now let me see, I'm going to be moving everything away from the x. That's away from the left-hand side. So I'm going to be subtracting 5. You know why I'm subtracting 5. Opposite of adding 5. So this becomes 0. 3x plus 5 minus 5 equals 3x. And whatever I do to the left-hand side, I have to do to the right-hand side, so that equals 21. Then we see 3 times x. I want to get rid of the 3 times. If I have 3 x's, how much is 1x? Oh, divide by 3. Divide by 3. So now x equals 7. If I wanted to figure out if that was right, I can check by doing 3 times 7 plus 5. Does that equal 26? 3 times 7 is 21 plus 5, does that equal 26? Let me see, 26 equals 26. It checks. Now, what do we do here? There are x's on both sides of the problem. I'm going to move the smaller pile of x's. It's always easier to move the smaller pile. When you're working on a farm, do you want to move the big pile of manure or the small pile of manure? You always want to move the small pile manure if you have a choice. So I subtract it. Why? Because there's a little addition sign right there. It's positive. So I'm left with 4x minus 7 equals negative 5. Set negative sign, the minus 5, that comes down. Okay, now I am going to add 7, 4x equals positive 2. When I divide by 4, I get x equals, yes, 1/2. Okay, now here, big idea, the big idea. The big idea is fraction bar is like parentheses. So you do everything outside the parentheses first. I'm going to multiply both sides by 2. Multiply both sides by 2. I get x plus 8 is negative 12. Now, I could distribute a 1 through there. So this is just x plus 8 is negative 12. Subtract 8, x is negative 20. Check that on the calculator. Yep, it works. A little bit more work here. Let's distribute, combine like terms, solve. What'd you say, Mr. Bryce? I said we distribute, combine like terms, and then solve. That's what you always think. Okay, that's what I always think. So we distribute. 6 times x is 6x. Not done. 6 times 4 is 24. Not done. Oh, no, not with the 6. Shame on you. Negative 2 times x is negative 2x. Negative 2 times negative 1 is plus 2 equals 2x plus 20. Draw the big line. Combine like terms. 6 minus 2x is positive 4x. 24 plus 2 is positive 26. That equals 2x plus 20. What are we doing? We're doing distributing, combining like terms, and solving. So we're still combining like terms, technically, by moving the 2x's to the left-hand side. So we get 2x plus 26 equals 20. Subtract the 26, and I get 2x equals negative 6. Divide by 2, I get x equals negative 3. Remember, if I'm going too fast for you, hey, just listen to it again, okay? Or ask me in class. It's important to understand that each step in solving these operations can be justified by using any of the real properties. Okay, from the last lesson, a property of equality, such as the additive or multiplicative properties. Okay, additive inverses, multiplicative inverses, things like that. Justify each step in solving the 2x plus 7 plus 4x equals 44. Now remember, I didn't say parentheses in there, but you saw them. Using either a property of real numbers, commutative, associative, distributive, or a property of equality. Property of equality. Ooh, property of equality. Test question, property of equality. The additive or multiplicative inverse. Okay, so what did we do first? From here to there, looks like we distributed, right? Now, I want you to kind of like be ahead of me a little bit. Okay, so you can hit pause and try to answer all these on your own and then check your answers. So I multiplied everything to 2x and the 4. There we go. Had that. Now, let me see. The 2 and the 4 are there, 2 and the 4 are there, but the x's disappeared. Wait, I got too far ahead of myself. Okay, so what happened between these two steps? 2x and 4x, nope, that's a 14. So the 4x, they changed, they commuted. They changed, they commuted. Now, a second ago, I was just saying, looks like the x disappeared. It was factored out. But guess what? Factor is not a property. Whenever you think I factored, I really distributed. What happened here? It looks like we added the 2 and the 4, and then we put the x there. And so I hit pause for a second and said, what happened? Oh, no line. That's combining like terms, okay? So here, we had the 6x. Looks like, oh, test question. Property of equality. Which property of equality? That's the additive. Now, if you're not listening to me and you're only like have it on mute and listening to your music, you just missed a test question. Okay, so that's the additive property of equality. But Mr. Bryce, you're subtracting. Hey, you know, there is no such thing as subtraction. It's really just adding a negative number. Now, what happened here? Looks like we combined the positive 14 and the negative 14. Oh, see that? Negative 14 on both sides. Additive property of equality. You have to add the same thing to both sides of the equal sign. Okay, now, so that combining like terms. Multiplicative property of equality, but we're dividing both sides by 6. Yes. Multiplicative property of equality. Bingo. And that is page 5. Let's see how much time we've done. 7 minutes, 8 minutes in 2 seconds, 1 second, 8 minutes. Okay, so on the next page, I want you to notice here that some strange things can sometimes happen. Sometimes we get no solutions. That's a horrible highlighter. That's a much better highlighter. We get no solutions. In that case, you have to write inconsistent on your text. And other times, we get all solutions. All numbers work. What's that called? That's called an identity. Okay, don't get those two confused. Inconsistent, nothing works. Now, how do you know if something works or nothing works? Well, let's solve this problem. So the first thing we do to solve this problem is we distribute. And then we get 3x minus 6 plus x minus 5. Now we're going to combine like terms. 4x minus, hang on, that's a plus 6, plus 1. And then over here, we get 4x minus 8. Oh, if I subtract 4x from both sides, what do I get? I get negative 8 equals 1. Never. That's inconsistent. Why? Negative 8 never equals 1. You have to write that whole thing down. An identity is an equation that's true for all values. So consider this. First of all, test, really? Test, plug it in. Okay, let's plug it in. Hey, wake up, wake up. Listen to this. I plugged 5 into the left. Do you know what I plug into the right? 5 again. Why? Well, you plug 5 everywhere you see an X. Don't do 5 on the left and 3 on the right. No, 5 everywhere you see an X. Then you type this into your calculator and see what you get. Well, how about that? 8 equals 8. That means it is, well, it doesn't mean it's an identity. It means 5 is the solution. Now, if we do the same exact thing for 3, we're going to see if that's true too. 2 equals 2. Okay, now I hit the pause there because that's not the important part. What's the important part? Right here. 2x minus 6 plus x minus 1 equals 3 parenthesis x minus 3 plus 2. Okay, what do we do to solve it? We combine the like terms. We get 3x minus 7 equals 3x minus 9 plus 2. 3x minus 7, combine these like terms, equals 3x minus 7. What, did I stutter? Right here, we know they're exactly the same, so it has to be an identity. Because 3x minus 7 is exactly the same thing as 3x minus 7. Now let's say you didn't know that, and so you subtracted 3x from both sides, and you get negative 7 equals negative 7. Still an identity. Okay, which of the following equations are identities, which are inconsistent, and which are neither? So we're looking for 3 different answers. We're going to do B and D here because we're running out of time. Very important, very important. We subtract 8 first. Remember, the fraction bar acts like parentheses right there. So I'm going to subtract 8 from both sides. We have 4x plus 2 all over 2 equals, subtract the 8, right? I hope I said subtract the 8, equals 2x plus 1. Now what do? I multiply both sides by 2 to get rid of that divide by 2. 4x plus 2 equals 4x plus 2. Oh, identity. Now let's do D. I have the divide by 4 on that side, but I'm going to combine like terms over here. 2x plus 1 plus 2x minus 2. Oh, I distributed that. 2x and then the minus 2 equals, can I divide everything by 4? Is the 16x and the negative 4 all divisible by 4? It is, so why don't I do it that way? 16x divided by 4 is 4, minus 4 divided by 4 is 1. Remember that little fraction rule that we learned last time? It's 16x over 4 minus 4 over 4, which gives us that right there. Okay, so I combine like terms. I get 4x minus 1, combine the two x's, combine the plus 1 and the minus 2, equals 4x minus 1. Another identity. There we go. This ends tonight's homework. Tomorrow, we'll be working on the next 2 pages in class. I'll see you then.